In lesson 5, we're going to talk about the 3 different types of layers that you're going to find in Photoshop. Now, typically, there are many different layers that you're going to find in Photoshop. As you build your layers palette, you're going to get layers all day long. But there are 3 very distinctly different types of layers that you're primarily going to be working with in Photoshop. The first one is a pixel-based layer, or what we call a rastered layer. The second is a vector-based layer, and the third is an adjustment layer. So let's first talk about the difference between a vector and a pixel-based layer. What I've got is a document right here for you. You can open up the document that's with this. It's called Layer Types, Pixel versus Raster. It's a PSD document, which is a Photoshop document. It's automatically going to have layers in it. What I'm doing for the sake of this demonstration, though, is I've already deleted the pixel layer because I want to show you how to raster a vector-based layer. So on the left, I've made a vector-based shape. How do I know it's a vector-based shape other than just looking at the fact that it's a shape? Well, if we look over here in the layers palette, you'll see that there is what looks like a little square box there, right? Where it says vector shape, right here, there's a little square box. If this was a pixel-based layer, that square box wouldn't be there. What that tells me is that this is a vector-based shape, or a shape that only knows the bounds of what I'm telling it to be in at that given time. And the reason why is because it's made up of numbers and figures and data and lines and shapes rather than pixels. Now, because we're in Photoshop, we are going to see pixels. But in reality, it doesn't know the bounds of a pixel because I can make this as large as I want or as small as I want, and it won't be rasterized to that or stuck to that because it doesn't know the bounds of a pixel. In order to make this easier, let's go ahead and press Command or Control J on this one if you don't have it deleted. If yours already has another thing over here in the pixel area, don't worry about deleting it. I'm going to press V for the move tool and move this right over here above where it says pixel. Okay? So now, in order to make this a pixel-based layer, I need to right-click on it and rasterize that layer. So what I'm telling it is, take your vectors away and raster it down to pixel-based information. This is where things get really interesting. It's because of the nature of how a vector-based image is built and how a pixel-based image is built that you're going to see drastic changes to both of these shapes that we have here, respectively, even when we do the exact same thing. So what I'm going to do is I'm going to double-click on this and I'm going to call this pixel layer. So I know the difference between the pixel layer and the vector layer right here in my layers palette. Where this is vector shape, I'm going to click on it, press Command or Control T, and I'm going to press Shift and Alt and just drag this down. Basically what I'm doing is I'm transforming this to a small size. Press Enter. Now I'm going to go over to this pixel-based layer. I'm going to press Command or Control T, press and hold Shift and Alt, and make it smaller, about the same size as the one on the left-hand side, roughly. Okay. So now what I've done is I've essentially taken that vector-based layer and the pixel-based layer and shrunk them down. Once I press Enter to that and commit to that, you would think that I'd be stuck with this, right? Well, if I click on this vector-based shape and press Command or Control T and enlarge this now by pressing Shift and Alt and dragging it up and making it large to the point that's about to touch that vector at the bottom and press Enter, you'll notice that I still have that maintained stroke path in magenta around the shape. If I come over to this pixel-based layer and press Command or Control T on it, press Shift and Alt and make it bigger, look what happens. It interpolates or pixelates. Why is that? Well, that's because it is a pixel-based image. We told a vector-based image, which is made up of lines and shapes, to then become pixels, shrink it down, and then expand it. Because it's still vector-based, it doesn't know the bounds of a pixel. Remember I said that at the very beginning of it? Now you're seeing how a vector image doesn't know the bounds of a pixel. Because it is a vector-based image, I can make this as large as I want. I could turn that vector-based image that you see right there into something the size of my house and print it on the side of my house, and you would lose no data whatsoever. We know that if we were to take a pixel-based image and blow it up via image size like we showed before, or by just actually making it physically bigger like we did with the transform tool that I just showed you here, it's going to interpolate. It's going to start adding pixels to it because you told something really small to get to be something really big, even though we started out with something big. The thing is here is that once you rasterize a layer and you make it smaller and you shrink it down and you commit to that, it's going to restrict the pixels to those dimensions. So anytime you want to blow it up, it's going to have to interpolate or try to make pixels exist where pixels should not exist in order for it to get that size. So now the question is, what's the application for this? Why can't every image just be a vector-based image? Well, it doesn't necessarily work that way. our images, our cameras, take pixel-based images. That's why we can't take that pixel-based image and make it as large as my house. It doesn't work that way. It'll take those pixels and it'll interpolate and it'll start adding things where things didn't exist. In the vector world, however, it's made up of lines and shapes. We often find this in text. When we're working with text in Photoshop, text is vector-based. It's not pixel-based. That's why when we type with text, it can be really clean and have these very beautiful edges on it and not be pixelated. Text and shape are vector. Pixels are anything that we add with, say, a brush. If we brush on with the color blue on this image or something like that, that would be a pixel-based adjustment. Now, depending on how big we make that brush, when we start out with, is different than if we were to brush on here and then make that brush size bigger. See what I mean here? So pixel-based layers can't get much bigger than they already are without interpolating, whereas a vector-based image knows no bounds of pixels and can do whatever it wants. The third outlier here that we have is something called an adjustment layer. An adjustment layer doesn't know the bounds of any pixels, it doesn't know the bounds of any vectors, and the only thing that's restricting it is maybe its mask, and that's it. So what exactly is an adjustment layer? Well, an adjustment layer is a layer that goes onto your image and makes mathematical decisions for you based on what you tell it to do. I know that sounds very vague. Let's go ahead and close this down. Let's go ahead and open up the example images that we have for this lesson, which would be these two example pixel layer 1 and pixel 2. So these images, if we look at the size of this image, we go to image size. I want you to see this because we're talking about the bounds of an image. 480 by 720 at 72 pixels per inch. Image size, this one's much bigger, almost 4 times as large. So what an adjustment layer is an adjustment layer is something that goes on top of your working document like you have here and does some mathematical equations or mathematical changes. You can find those adjustment layers by clicking down here and loading up any of these adjustment layers. That's my preferred way to do it. There is another way. If you go to Window and you go to Adjustments, this is your adjustments window. If you want to put this in your secondary toolbar, by all means go ahead. You pop it open. It's going to give you icon-based adjustment layers. I don't really like this. I know that by some of the visuals here, I can kind of gather what they're going to be. But what I'd rather is to go down here and see what type of adjustment layer I'm getting by what I read. So let's do something simple like a brightness and contrast, or let's do exposure. Exposure, by just bringing the exposure up. What's happening here is this adjustment layer is going on top of all of the work that I have done underneath it, and it's adjusting it to a +3 exposure value. If I turn it off, it's not doing anything. So what's happening is this is acting like a layer or a pair of sunglasses. If I were to put a pair of sunglasses on my eyes, my vision doesn't actually change, but the way I see the world changes. The same thing happens with an adjustment layer. The image itself doesn't actually change, but the way you see that layer changes, or all the work underneath changes. When we take off those sunglasses or turn off the preview of that exposure, it doesn't happen anymore. So notice how I said this knows no bounds. Well, why does it know no bounds? Watch this. If we take this background layer and we learn what we learned from before about image sizes, and we were to move this background layer onto this image, notice how when we bring this image over to here, it constrains itself to its size or its boundaries that it existed in its own document, which was at 760 by whatever that was, 400 or something like that, right? Well, when we bring that exposure layer over, watch what happens. If I click and hold this and bring it over, notice how it doesn't just affect just this image here. It affects everything. Why is that? Well, that's because an adjustment layer knows no bounds outside of the document. It could be as big, that document that you move that adjustment layer to could be huge, and it doesn't stay restricted to the document that it was built in, unless you use something like a mask, which we will talk about in the next lesson. So looking at this example here, this exposure adjustment layer, you would think would only fit to the size of this canvas. So why, when we move this exposure over to this image, did it not just work on this image? It worked on the entire photograph. That's because it knows no bounds. It knows no pixel bounds, it knows no vector bounds, and it can adjust any image whatsoever. So those 3 types of layers that we had were the pixel layer, the vector layer, and the adjustment layer. Remember, a pixel layer is restricted by the pixels. If you try to make it bigger, it's going to interpolate. If you make it smaller and commit to it and then try to get it back to its original size, it's going to interpolate. A vector, it doesn't care. Make it bigger, make it smaller, make it the size of my house, make it the size of the entire United States. It doesn't care. It only knows the bounds of how big you're telling it to be at the given time. An adjustment layer knows no bounds as far as vectors or pixels are concerned, and it will allow itself to adjust anything in the confines of the mask that's on it, which we're going to talk about masks in the next lesson, where we talk about layer modifiers.